For question 2, we're going to use a time series data. We're going to plot the data, and then we're going to answer a couple questions about it. Then we're going to develop a 3-month moving average and compute the MSE forecast for month 8. Then it's given us a exponential smoothing of 0.2, and we're going to compute the MSE and forecast for month 8 of the exponential smoothing. Then we're going to compare these to determine which is going to be the best forecast. And then lastly, we'll use trial and error to determine what the smallest MSE is. Because remember, the smaller the MSE, the better. So, as before, I'm going to copy and paste my data. And I just opened another sheet in my same workbook I was working in earlier. Oh, good. I was hoping that would happen. Okay, so if this happens to you where everything loads in one cell, what works for me is to capture everything except for the very last value, which I will manually type in. I don't know why that works, but it works. So, and I believe that was a 15. So the first thing I have to do is it wants me to plot the data. So I will select all of the data, insert, and I'm going to scatter plot. No, it didn't scatter plot, did it? It had the line. So let me do it like this. So select all of the data, insert, recommended chart, and this is what it wanted. Then I need to refer back to my reading and see which of these charts is the same as mine. And then I need to say what pattern exists. And you should have read about this in the chapter and should be able to answer that question fairly easily. Okay, now we are going to make a table like we did before where we have the month, the value. We're going to create a 3-month moving average and an exponential smoothing using a constant of 0.2. So to do this, I'm going to grab my data, copy, come down here and paste it with the transpose to get it in the right order. I can't do 9 point. Okay, to make this easier when we're working the formulas later, I go ahead and create a cell with my exponential smoothing constant that I was given in the question. So remember, when we forecast, we use the value from the previous month. But if we're using a 3-month moving average, that means that I have to have 3 months of data before I can ever get 1 month forecasted. Okay, because I'm going to say equals the average of the first 3 months. And so month 5 will be the average of months 2, 3, and 4. And month 6 will be the average, A, B, G, of the 3 months prior to that, which will be 3, 4, 5. Month 6 will be the average. I'm sorry, month 7 will be the average of 4, 5, and 6. And remember, we're going to be predicting month 8. So we'll go ahead and add that. And month 8 is going to be the average of 5, 6, and 7. You have to know how to spell, I guess. Equals Average. Who knew there was spelling in math? 5, 6, 7. Okay. And then I do want to get these all to the same. And I always like to look and see this one, 2 decimal places, but don't, it said do not round your intermediate. So let's just get them all the same. Okay. I'm going to highlight that because that is going to be one of our answers when we go on to MindTap. See, because it said the forecast for month 8 is, it's going to be that amount right there. That's our forecast. It wants it to 2 spaces. So for me, it's 1833. It'll probably be a different number for you. Okay. So for our exponential smoothing, we have to use the previous month's data, and I don't have any in month 1, so I can black that out. There'll be nothing there. So for the month 2, since there isn't already an exponential smoothing here, I use the value of month 1. And just to, in case you go back and look at my spreadsheet, you want to know where I got that, I'll put that in. For month 3, we will use this formula that I've put here for you, where A is the smoothing constant and Y number is the value or possibly the smoothing. Let me just show you how we plug this in. So the formula says Y3 equals A times Y2, value of 2 right here, plus 1 minus A times Y1. This Y1 is going to be the exponential smoothing of the number before me, before the one I'm on. Okay, let's do this one. Equals the constant smoothing times the value of the previous month plus 1 minus A times the previous month exponential smoothing. I don't know, I don't think I can pull this down, but let me see if I can. Try it like this. No, I didn't think so. Okay. Because it's a pretty detailed formula. Okay, so for month 5 equals my constant times the previous month's value plus 1 minus the constant times the previous month's exponential smoothing equals constant times the previous month value plus 1 minus my constant times the previous month exponential equals, you get the picture? You have to sit here and watch me do all of them. Well, there's just the one more left. So that's times the previous month's value plus 1 minus times previous month. Now, remember, we're predicting month 8 here. So I'm going to go ahead and fill this one in. I have enough information to do that. So you're going to be asked in Cengage on C, the MSE and a forecast of month 8. It require round your answer. So the forecast month 8 for the smoothing is going to go right here on the second part. We still haven't done these two blanks yet. Okay, so to complete B and C, we've got to determine the MSE. We're going to determine the MSE for the month 8 forecast, and we're going to determine the MSE for the month 8 using the exponential smoothing forecast. So we're going to do both. So I've made this, you don't need that, I've typed it down here. So I just give them title however you want, but you need a title for them. Okay, so we're going to use these two formulas. So to do the 3-month moving average equals, make sure that you type that in and don't let Excel give you options to select one because there's several different ones. So just go ahead and type it in. And then the first thing we put in is the months 4 through 7 value, which I gave you down here. See, month 4 through 7. So that's the value of months 4 through 7, comma, then you're going to do the 3-month moving average for months 4 through 7. Close that out, and then divide it by 4 since there's 4 months. Then the exponential smoothing, to determine that value, it's the same, except for now, because I have data all the way from month 2. So over here, remember, I couldn't start filling in information until month 4. Over here, I had it from month 2. So I'll do the same thing, but I'm grabbing my information from months 2 to 7. Two through 7, comma, 2 through 7. And now I had 6 values, so I'll divide this one by 6. And it wanted these two decimals. So I'll take that down one more. And these are the values that will go with these values to complete the question. So in part B, the MSE is this value right here that we just collected. And in part D, this is the other part of part D. So basically what you're looking at is, let's see if I can write on this, draw. These two numbers are B, and these two numbers are D, where this number goes in first. Cool? All right. So we have B and B. I keep saying D. I'm sorry, it's C. Hello, it's C. Then it wants us to compare these two. Wants us to compare these two MSEs and determine which one is the better forecast. I can do that with this formula. Index C33 for me is the title. Remember when I told you give your box a title? So it's the titles, comma, match, men. So I'm telling it, and the reason I say match men is because I know that the lesser of the MSCs are better. So I can really look at this and tell you 3 month is going to be better, but you're going to need to do this at the bottom. I'm going to show you, you're going to have 100 figures to pick from. You're going to have to use the formula. So let's just go ahead and use it. So I'm trying to determine between these two numbers. Tell it these two numbers again. Oops, nope, these two. And then comma 0, and what did I do wrong? Earlier I did this, I put a period instead of a comma. Matchman D33. Oh, I know why. That should be the, let's start over. It's index, these two. Just the title, comma match, men. I need my values, and I had selected those for some reason. And then I reselect those values again, comma 0, and it tells me 3 month moving average. So I would select that 3 month moving average there. Now it wants me to use the trial and error to find the value of an exponential smoothing coefficient alpha that results in the smallest MSE. Okay, there's a little more to this. We're going to build a one-way data table. We're going to start that data table off by saying when my exponential smoothing is, remember my exponential smoothing I found. So I want that there. Then I'm going to say 0 0.00, 0 0.01, all the way down. And I want that to have the digits for me so that it, I'm going to go all the way down to 1. So since I am on row 55, I know that I can go down oops, I don't want to do it like that. So grab these two. If I go down to 155, it'll be at the 1. Now I need to fill in these values, and this is how we're going to do it. We're going to capture all of this, even though I know I'm capturing vacant cells right now. Go down to 155. Okay. Now I'm going to say data, what if analysis right here, data table. I'm not putting anything in on row input cell, on column input cell. You can't just type the number, you have to click the cell. I'm putting in my smoothing constant. Remember from the beginning, going back to that, I tell it okay, and it built my table for me. So there's 101 values there. So remember, because I'm doing trial and error, that's my trial and error. So let's go back up here. Here's how we're going to finish this problem off. Just like before, my optimal A is going to be this formula equals index. And it's going to be B54. I moved my data around. You see, equals index it's going to be all of these comma, match, min, and then these values, leaving out that the exponential smoothing that we found earlier. So we're just dealing with these 100 numbers. Close that, comma, and now I'm just going to type it instead of going through it again. C, it'll match 55 to C1, 55, comma, 0, and it wants 2 decimals, so my answer is 0.31. And that is